is I'm Mr. Alex Afezi of Kumasi Girls Senior High School. I'm a maths teacher, and in this era of coronavirus, staying at home can be boring, but if you are going to learn maths, I think you are really going to enjoy yourself. You have so much time. Now you can watch these videos online. You can have to subscribe to the videos by looking down the link, and make sure that you follow the steps. Let me know where you find difficulty. I'll be sending you very good feedbacks. All right, so today, what are we going to do? We are here to start indices, one of the topics that students find difficulty. I think those in JHS will really benefit as you prepare for your exam. All right, so without wasting much time, let's get started. All right, indices. So what is indices? All right, so indices are powers of natural numbers. Powers of natural numbers. So just imagine if you want to multiply 2 as many times as you can. Sometimes it becomes so difficult because the numbers are so many. We can have a shorter way to write them. So that's the concept. We are going to have shorter ways to express work that could have been very difficult. So let's look at indices. Now, if you look at the board, this example, 2 raised to the power 6, this means that the 2 is going to multiply itself 6 times. One, 2, 3, 4, 5, 6. So when we say 2 raised to the power 6, what we are saying is that instead of writing 2 times 2 6 times, you can decide to write it in a shorter form, where you write 2 raised to the power 6. So instead of this long thing, we can write it in a shorter way. And that is the concept. We are looking at work that can be contain a lot of numbers, and we are having a shorter way to express them. So now let's look at what powers of natural numbers means. Now when we talk about powers of natural numbers, let's go through. Now we are moving on with the concept. Please, for maths, what you have to really understand is not the question. Is the concept. That is what you are going to be examined on. Now, when we have a raised to the power b, a raised to the power b, the a, which is a whole number, is what we call the base. Now, this power here is called exponent or index or power. So if you want to read this, you are going to say a raised to the power b, or a index b, or a power b. So depending on how you want to say it. So now we are in them. Everybody should be able to state a number raised to a power as a form of indices. So these indices, we have shorter ways of expressing them. So now our first example is that we are going to have a longer multiplication which is repeated, and we are going to express it using only one term. Okay, so let's go to the example. Now let's look at the instruction. We've been asked to express these as a single term. Now, This is 2 multiplying itself. How many times? We have 1, 2, 3, and 4. So what is the shorter way to write this whole thing? Now, the 2 here is being repeated. And so we are talking about the 2. And how many times? So we are going to write the 2, and it has been repeated 4 times. So in short, 2 times 2 times 2 times 2 can be written as 2 raised to the power 4, or 2 index 4. And so this is how to write something that looks a little bit longer in a shorter form, making the work so easy. Just imagine you have a communication with a friend and you want to describe the number of times 2 is happening. If it's being multiplied by itself, it's an exponential sequence. You cannot say that I had 2 times 2 times 2 times 2. You can just say it in a short way. 2 raised to the power 4 was my final outcome, and everybody will get the concept. Now let's pick our second example. Now in the second example, you can see that we have other numbers coming into play. We have 2, we have 3, and then we have 7. So in a shorter form, we are going to look at the common ones. And this is going to be our final outcome. The 2's were 2, so we are going to have 2 happening 2 times. The 3's were also 2, so we have 3 happening 2 times. Then the 7 is 1, so we have times 7. If you look at these 2, this is a shorter way of writing this long work. And so we've gone through the examples. Now this is the concept. Now there are some rules that govern these indices that is going to make the work very easy as we encounter bigger problems. So now let's go and look at the laws of indices. These laws are the concept that is going to govern the whole thing. So the specific objective is that at the end of this lesson, you should be able to solve questions related to indices using these laws. All right, let's go to the laws. Now, we are going to bring the concept out. Now, let's look at how we can multiply these 2. Now, let's assume we've been asked to multiply these 2. These are in a bracket, meaning this is 1 term, and then we want to multiply it by these 2. Now, based on what we've just learned, the 2 is happening how many times? 1 and 2. So here we have so now we have 2 times 2, and then the other side here we have 2 times 2. Together, don't you think it would be very easy if we write all of them together by expanding? And so here we are going to have 2 raised to the power 4. And this concept is very easy. But it took us a lot of steps to arrive here. And I'm telling you that maths is about a problem-solving procedure. So here we can have a shorter way to get the results in time. Now, if you look at this example, the 2's here is the same as the 2 here. Forget about the powers for now. It means the bases are the same. Now, when the bases are the same, we could have written it this way. Then let's see when we add the powers, what will happen. Wow. So it means that somebody might take his time to solve the work this way. Somebody would also want to go through the work this way. And let's look at the answers. The answers are the same. This is an easier way to solve. And so this is what we call the first law of indices, the product law. Now this product law only works when the bases are the same. Now we have a raised to the power m times a raised to the power n. What is common here? What we are really interested in is that we want to have a common base. Once the common base has been satisfied, it means we can apply the law. How do we apply the law? We write one of the bases, then we add the exponents or the powers. So that is pretty easy. The concept is the bases are supposed to be the same or common before you can add the exponents. So let's have an example. Now, if you look at this particular question, simplify 3 squared times 2 raised to the power 2, or 2 squared. Here, if you are not really looking at the law that we just read, it means you are not law abiding. And if you are not law abiding, you cannot really get this concept right. The law says the bases are the same. It means these two, we cannot apply the law. The bases are not the same, even though the exponents are the same. The law really focuses or emphasizes on the bases. So in this a question like this, we don't know which of the bases to write. So the law will not apply here. But this question can be solved in any other way. But my focus today is to take you through the laws. So a question like this, we are not really going to solve it. It does not conform to the laws of indices. But you can decide to find the actual value. 3 squared is 9 times, and 2 squared is 4. So it means you can multiply your 9 by 4 and you have your 36. And that is how this work is supposed to be solved. We can't apply the law. So take your time, a small recap, then we go to the second law. Make sure the bases are the same. Make sure the sign is multiplication. This law is called the multiplication law of indices. All right, so we've established this law. We are going to take our time and look at some few questions where this law is applicable. Okay, so the law is saying that if you are multiplying 2 or 3 numbers and you realize that the bases are the same, forget about the powers. You are going to write only one of the base, as in here, and you are going to add the powers. So let's try ourselves with some few examples. All right, now we have a question here. Simplify 2 index 3 by 2 index 2 by 2. Now, if you realize these work, if you look at the 3 figures here, all of them, the powers are clearly seen. This 2, it looks like it has no power, but it has a power. Now, a number without a power is the same as the number raised to the power 1. So first, make sure you write the powers which are hidden so you can see the trick. Bravo. The powers are clearly spelled now. Now let's apply the law. Let's look at the features. The first thing is, it's called a product law. Let's see whether the multiplication sign is in effect. Good. The multiplication sign is clear here. The next thing is, look at the bases. Are the bases the same? Wow. 2, 2, 2. The bases are the same. So we qualify to really apply the law here. So now what are we supposed to do? You write only one of the bases. What's the next step? Add the powers. So our final result is 2 raised to the power 6. And this is what the concept is really about. When the bases are the same, you can write one and then add the exponent. Why are we adding? Now remember that multiplication is called repeated addition. Now just ask yourself, what is 2 times 4? 2 times 4 means you are going to add 4 2 times. All right? So you keep adding. When you ask to recite your 4 times, you have 4, 1 will be 4. The next figure, you are supposed to add another 4. So normally, multiplication and addition, they go hand in hand. So multiplication law, addition of powers. All right, let's make our second example. All right, so math, we really have to go for problems that we can solve. The concept still remains the same. Remember, first, make sure you can see the product sign clearly. Then look for numbers with the same basis, not the powers. These are 2 with the same basis. You can decide to group them so that you can see them clearly. And the 3s are also 2 with different powers. The next thing you have to check is, if anybody doesn't have a power, remember, a number without a power is the same as raised to the power 1. It means the number is appearing only once. So let's do that trick. All right. Now, that trick has been solved. Normally, teachers try to hide these things from students because they forget. Be smart enough, don't be taken by surprise. All right? Now, let's look at the 2s. How many do we have here? So that's 3. We are going to write them only once. What do we do to the powers? Add. Remember, the 3s are different. The basis would also work when the figures are different. So for the 2 3s, okay, let's move on. Now, our final result, we have 2 raised to the power 6 times 3 raised to the power 6. Can we move further? No. The laws do not apply here. So in this case, if a teacher is looking for only one answer, it means you are supposed to generate what 2 raised to the power 6 means and multiply by what 3 raised to the power 6 also means. And then you can write a final answer. Remember, I'm not interested in the final answer. My interest is the concept. Once you get it, you will get the final answer. So that's the multiplication law. Now let's move on to the next law of indices. All right, so 3 raised to the power 5 divided by 3 raised to the power 4. Here we are looking at the division law. We can do the same thing we worked with when we were looking at the multiplication law. So here we are going to write only one of the base. Then we are going to subtract the powers. And the powers, we are going to have the first power minus the second power. And this is also giving us 3 raised to the power 1. And that is 3. So you can see that with the 2 procedures that I've used, we are coming out with the same answer. Now, what we are trying to say is that the questions could become very challenging. So stick with the concept. The concept will solve any difficult question once you are applying the laws rightly. Okay? Now, we would like to look at the third law. Now, what is it going to be about? Now, we've talked about multiplication going together with addition, division going together with subtraction. Now, let's look at this example. You've been asked to simplify 2 raised to the power 2, all into bracket, raised to the power 3. So this one means that we can have the expanded form so that we can really see what we are about doing, right? So 2 raised to the power 2 raised to the power 3 means that you are going to multiply 2 raised to the power 2 3 times. Wow. Now there are no brackets. What law can work with these ones? We've studied 2 laws today. We have studied the multiplication law and then the division law. What sign is prevailing here? Multiplication. So it means that we can apply the first law that we did, which was the product law. And how do we go about it? We write one of the bases. Then we add the powers. And our final result is 2 raised to the power 6. This is an explanation of what is really happening. Now, what is the law saying about something like this? Now, let's look at the concept. We are not always going to be getting natural numbers which are easy to work. We can have decimals or fractions. So the concept will make it easy for any kind of number we have in a question, okay? Here we have only one of the base. So what we can do is we write that base and then look at what we are going to do to the powers. Wow. Let's see what happens when we multiply them. We've gotten 2 raised to the power 6, just as the work we did here. So what it means is that instead of going through this whole thing, changing from this to the first law, which is the product law, adding before you come back to the final answer, you can decide to apply this. You write the base, you multiply the powers, and you are good to go. So what is the concept? Now there's a general formula that governs this, and we are saying that so a raised to the power m, all raised to the power n, we are going to have the base, then this time we are going to multiply the powers. And when we multiply m and n, what are we going to get? Multiplication is commutative. 2 times 3 and 3 times 2 are all going to give you 6. So we can write mn or nm. In math, when you're asked to multiply 2 variables or alphabets, in this case we have mn. You are going to write them together. So we have, so you can decide to write mn or nm, and both of them you are correct. Now let's try and see if you can remember all the 3 laws. All right, so let's try and see if you can remember all the 3 laws that we've discussed. Okay, so which of the laws is the first one? Obviously, you can see product here. So that is the product law. That means multiplication, and I said it's repeated addition. So how do we go about it? We said you write only one of the bases. Then you add the exponent. The division law. Same basis, we can apply the law. Remember, if the bases are not the same, these laws do not apply. I want to repeat for emphasis. If the bases are not the same, these laws do not apply. Now, these are the 3 main laws that we would like you to go through. And then thank you for going through this. We are going to look at a few properties and then we are going to solve some questions. All right? Now, the first property we would like to talk about today is a number raised to the power 1. What does it mean when we say a number raised to the power 1? What it means is that how many times that the number appeared. So a raised to the power 1 is asking you how many times is the a appearing. And obviously the a is appearing once. So any number raised to the power 1 is the number itself. Let's pick an example. What will 4 raised to the power 1 be? How many times that a 4 appears? So it means the power here describes the number of times the natural number here appears. And so here too we have 4. And that is all about the first property. Any number raised to the power 1 is the number itself. And that is why in our subsequent examples, those that the powers were not written, if you remember, I wrote the one there for you to see the number of times they appear. Let's look at the second property. A number raised to the power 0. How are we going to describe a number appears 0 times? It looks weird. But take a look at something like this. Simplify. 2 raised to the power 2 divided by 2 raised to the power 2. Wow, this is the second law. Let's try and apply this division law and see what will happen. Here we write 1 of the base, and because it's division, we are going to subtract the powers. Wow, we are coming out with 2 raised to the power 0. So it means that it's possible to have a number raised to the power 0. And when does it happen? It happens whenever we divide a number by itself. If the number is by itself, it means the bases are going to be the same. The exponents are also going to be the same. And because of the division sign, we apply the law for the division. We write only 1 of the base, subtract the powers. First power minus second power here, we have 2 raised to the power 0. Any number divided by itself is 1, except if the number is 0. And so today we are saying that any number which is a natural number raised to the power 0, we are going to get 1. This is a very important remark. The number should be a counting number, or it should not be a number which is equal to 0. Because 0 raised to the power 0 is still 0. Okay? Now, let's go to one of the properties again. Good. Looks like we are yet to experience new things. This time, the power is going to be negative. How do we explain that a number appears a negative number of times? Don't worry. Any number raised to the power a negative number is a fraction. It's a fraction with a numerator of 1. Then the denominator is going to be the same number. And this time, the power is going to be what? Positive. So here, a raised to the power negative n, we are going to have 1 out of a raised to the power n. And remember, it's negative here, it's positive down here. And this is the concept. Any number raised to the power a negative number is the same as 1. So the 1 here is always going to be constant. So please bear that in mind. Let's pick an example. what is the actual value, or how can you write 4 raised to the power -1 in another way? Now the index is negative, and I said when the index is negative, it means we are going to have a fraction. And for the fraction, the numerator is always 1. And what's the power going to be? Is it going to be negative or positive? It is going to be positive. Now, this concept is really important when the questions become a little bit challenging. You will always have to remember this, okay? Now let's look at another property.